Hello YouTube, RJ. We're picking right up where we left off in part 3. Okay, so we've got the really bad one there taken care of. So let's see what we want to take out now. Guess let's just keep going right across here. So that's going to be 150 according to what I see here. Let's throw the meter on it, make sure. Don't want to change these thinking I'm changing one value and changing another, but according to the manual information, that should be 150 ohms. We'll do a quick check. Sanity check to see if that seems right. It's reading 62 ohms. But according, if you can see here, it's 3.3 here. The next one over is 150. So that's reading 67. Now maybe it has some in-circuit, effects making it read differently. That's very well possible, but we'll find out in a minute. Let's get it out. We'll get her out there and measure her again. Here we go with the bent over leads again. There we go. This solder sucking gun is the berries when you're doing this. Really helps. So let's spin it right in the wrong direction. Kind of in a bad spot for me here. Get the gun in there, but let's just try to clean all the solder off of it first. Try to get the solder off from around it best I can. That'll help me get it bent up, hopefully. Come on. She's fighting me. Sometimes it's a challenge when they've got them bent over sharp like that. You'll notice when I put them in, I bend them a little so the part doesn't fall out, but I don't bend them over. There we go. Hopefully we got that one out. So I don't bend them all the way over. I just bend them just enough that the part's not going to fall out while I'm soldering. And then that takes care of it. Get a little cleanup on this end here to get a little solder off, straighten her up a little better. A little bit more. Just a little solder on his end. There she is. Now, question. What's this thing going to read for resistance? Not horrible. Actually, that one's pretty good. It reads pretty well 150. But she's getting a new 150. Find her. 150. As I said, we're trying to improve this thing. So in the case of this one, even though that was reading 150 once it was out of circuit, these metal film, low ppm, more thermally stable resistors won't drift as much. 149.99. Nope, wait. 150.01. That's what I'm looking for. Okay. So I'll be skipping through a lot of this, as I said. So don't, if all of a sudden I'm down the road and a few more resistors changed or whatever, it's just saving time so you don't have to sit and watch so much to see this video. So I'm just thinking of you. I'm just thinking your time being valuable and wanting to keep you interested. Like I said, Get in the comments if you're if you think that you'd like to see me stay on the whole thing, or maybe you want to see less. Maybe you want to see less commentary about what I'm talking about and such. It's fine. Let me know. I'd love to know you guys' thoughts, so I can modify the channel to make it more interesting to you. Okay, what's the next one we're going to do? We're going to do another 150. He's right here. Okay, with that, the resistors are changed on this main board. The only question I had was whether I wanted to change these ceramic capacitors. I bought them. I'm thinking if you bought them, you probably ought to change them, but I'm going to go ahead and change these 4 ceramic capacitors, and then I'll come back. All right, we're back. As promised, I went ahead and changed out these caps. Glad I did, because these, can you see how shiny, maybe if I get the light right, can you see how shiny these capacitors are? They're sticky and gooey, as if something's leaking out of them or something leaked. The ceramics usually aren't a problem, but they were awful sticky and nasty. So we don't have to worry about it now. We know we've got that taken care of. So I've changed those caps. I've retouched every solder joint, you can probably tell. Grabbed the probes of the LCR and tested every contact to make sure every joint has good contact. Appears to be good there. The last thing we really need to do is, one is discuss the selenium rectifier. I kept saying diode, but it's a diode. It's a selenium rectifier. It was a prehistoric dinosaur version of a diode before they had silicon diodes. I talked about changing this. I said I'd do a little research. Here's what I found. Lots of people change them. I found a lot of guys that have been working with these meters from way back when they were first made and restoring, redoing, and they swear they've never found a bad one of these. They've never seen, you know, I found about 4 guys right in a row agreeing with each other. I've done dozens of these. I've done 50 of those. I've never found this go bad. I've never seen it go bad. It's so lightly loaded in this unit for what they put in. So I'm going to leave it alone, leave it original, you know, and just a decision I made. So I'm going with that. So at this point, what we're down to is some of the precision resistors. When I went through and started, you know, when I went through and did the read, some of them were pretty high. This one was 2.2% out. This was 2.9% out. This one was 0.79. This one was 0.96% out. So what I went through is not every one of them. We'll get that done. And then the next thing we're going to do is clean all these contacts. We're going to get our deoxit out. And no, not spray. We're not going to spray it all over the wafers, because these old wafers, you don't want to do that. If you don't know that, don't spray these with deoxit. These wafers absorb it and create all kinds of issues. I use the little straw one with my little show you here, with my little pointed cotton swabs, and I go in and I clean the contacts. So we'll get them cleaned up, and I'm thinking that's really it. We're ready to put this thing back together at that point. So let's get to it. Let's get these resistors we're going to change out. Now, why am I changing the resistors before I clean all this? Well, because when you're soldering, you're going to have flux vapor and stuff coming out and getting on the switch contacts potentially. So I want to clean it after we do it, if that makes sense. So anyway, let's look at some of the ones we're going to change. One is this 7 meg. So let's get that 7 meg out of here. I don't know if you can see it right there. Let's get him out. At this point, I'm ready to clean these contacts and sockets for the tubes, and it'll be time for assembly. So I'm using Deoxit D111, and what I'm going to do is just put some on, just wet this down with some. Like I said, the spray's easy, yeah, but man, you do not want to get these things just covered. You do not want to get these things covered with this stuff. That won't play well. So what we're going to do is we're going to rub a little on, just on the metal contact areas. And right now I'm just going to rub it on, and I'm not going to switch anything yet. And the reason is I'm just trying to get this cleaned, get a little on there, and then what I'm going to do is I'm going to take, now I'm going to switch it around. And I'm going to need some pliers to do that. I need to flip her up a little here to be able to do this. Rotate her through all the different combinations. So she's in a different position this time. I'm going to go back, put a little bit more on. Okay. Okay, that should help that switch. Now, I got to do the same thing on each level of the switch. So I've got 3 different levels. These are going to be a little tougher to do. Contact should be clean. Everything should be good to go. We are ready to start assembling. So I'm going to take a break, pick up a few things, get something to drink, and then I'll come back. We'll start assembling this unit, and hopefully you'll like what you see. Okay, update, change of plans. Started to put the tube in, played around a little just to see if it looked like things were working good. Looked like it was going to be a working unit, and it was just all over the place. I had the pot for adjusting zero was bouncing. I couldn't get the needle to zero. Move things around, things would jump up and down and do crazy stuff. I've, number one, decided to put a couple pots in. These pots are not in great shape. They're old and they're not smooth and steady. Not the same pot size wise, so I'm going to end up making a little adapter washer for this to fit the bigger hole. You know, got plenty of tools to do that with. We'll be able to get that done, no problem. So we're going to get these pots in to fix that issue. Haven't tested these pots outside the circuit. They seem okay at the moment. They're testing okay. But this stiff hard wire is just a mess. There's at least one that you move around and it makes and breaks. It's got a broke wire. It's broke somewhere. It's fractured somewhere in it. And it's just a mess. This was not, I don't know why they used this wire back then. But so anyway, I've got some new wire. I'm creating a whole new harness. I'm starting to put new wires on the board. So we're gonna create a whole new harness and bring it down this side, and all new flexible stranded wire, and just take care of this mess. So this is going to be quite the project as far as rewiring all this stuff. So I'll come back when I've got some work done to show you where we are and kind of fill you in. But the project's just taken on to be much more than originally thought. But these old pieces of equipment, it can be that way. And you know, I decided to make this nice. That's why I replaced all these resistors. That's why I'm doing what I'm doing. So I'm going to go ahead and make it nice. I'm going to make it as nice as I can. So this is another part of that. You know, make it nice. Make things that are going to be reliable and going to last for a long time. So I mean, we're going to get this done. So I'll be back, oh, probably a day or two from now when I've got a bunch of wiring done and have something to show you.